In this lesson, we're going to look at simplifying powers of I, and our focus on this lesson will be on positive powers of I, so positive exponents. And so basically what's going to happen is you're going to be given examples like this, and you'll be asked to simplify. So you'll be asked to simplify um, situations like I to the 23rd power, I to the 48th, I to the 72nd, and so on. So that's what we're referring to here. Now, before you can simplify these powers of I, we have to recall our basic definition. And so recall this definition, that by definition we had defined I to be the square root of a negative 1. All right, so this imaginary unit was defined to be the square root of a negative 1. So that's what we defined I to be as. You also learned in a previous lesson this idea. So if I is equal to square root of a negative 1, then do you remember what I squared is equal to? So let's think about this. So if I equals the square root of negative 1, and if I square both sides, so if I square both sides just like this, we see that I squared is going to equal, remember the square and the square root, they undo each other, so you're going to get negative 1. So by definition, if I equals the square root of a negative 1, then I squared will equal negative 1. Okay? All right. Now, one of the things we have to look at then is what about I cubed? So let's look at I cubed for a moment. I cubed. So the way you want to approach this is this way. So I cubed, you remember we're going to use some properties of exponents from a previous course. But do y'all agree that I cubed I can write as I squared times I? So remember, when you multiply like bases, you add exponents. So 2 plus 1 is 3. And we now know that I squared is equal to negative 1. So this right here becomes negative 1 times I. And so negative 1 times I is a negative I. Okay, so I equals square root of a negative 1. I squared equals negative 1. I cubed equals negative I. Now let's look at I to the 4th. So let's continue this pattern. So let's look at I to the 4th. Well, by using that same idea that when you multiply like bases, you add exponents, I can write I to the 4th as I squared times I squared. And so we know that I squared equals negative 1. All right, so negative 1 times, and this is also negative 1. And we know that a negative 1 times a negative 1 is a positive 1. Okay? Now let's look at I to the 5th. So let's continue on with this. Let's see what happens. So I to the 5th, I get this. So I to the 5th becomes I squared times I squared times I. Y'all agree with that? So just using that same stuff I just did, the same bases and exponents. And just because, remember, when you multiply like bases, you add exponents. 2 plus 2 plus 1 is 5. Now, in a little while, you're going to learn an easier way than to do all this. But for right now, let's just look at it in terms of what we already know. So I squared we know is negative 1 times I squared is also negative 1 times I, right? Okay, so negative 1 times I is, remember, negative 1 times negative 1 is positive 1. 1 times I is I. All right, so we're back to the fact that I to the first is just I to the second is negative 1, I to the third is negative I to the fourth is 1, and then I to the fifth is I. Let's do one more, and then I want to show you a pattern. So I'm going to go to I to the 6th. Now the way I'm going to do I to the 6th is, rather than doing all of this, I just want to remind you about something else, and this is going to be needed when these powers, when these exponents become much larger. So do y'all agree that I to the 6th, I can write it as I squared? Now you're always going to use I squared with large powers, because I squared is easy to remember. That's just negative 1. Okay, so I squared is negative 1. So when we get large powers, always we're going to use I squared. And the way you're going to do that is this idea. So in a previous course, you learned that when you have a power raised to a power, when you have a power raised to a power, you multiply those exponents. So 2 times 3 is 6. So you see what I did? So I wrote, I wanted to use I squared because I knew I squared was negative 1. And so since I'm using I squared, you're asking yourself 2 times what is 6? Well, 2 times 3 is 6. So then this becomes negative 1 to the third power, and negative 1 raised to an odd power is always negative 1. And so I want you to notice this pattern. So let's look at this pattern that you may be seeing. Okay, so let's look at this pattern. So I have I squared, I cubed, I to the fourth. So based on what we just saw, we know that I is the same thing as I. We know that I squared is negative 1, right? I squared is negative 1, okay? We know that I to the third power is negative I. So I to the third power is negative I. We know I to the fourth is 1. Okay, I to the fourth is 1. And then if I continued on with this, so I to the fifth, I to the sixth, I to the seventh, I to the eighth, I want to show you what's going to happen. So I to the fifth we looked at. I to the fifth is if you can see it, it's right here. I to the fifth is I, right? So, and then I to the sixth we saw is negative 1. So I want you to notice what's happening. So you see this pattern? So you have I, negative 1, negative I, 1, I, negative 1. Then what do you think is going to happen here? What do you think I to the 7th will be? Well, I to the 7th will be negative I. Okay, so I to the 7th is negative I. Now, when we do this, that's you don't want to memorize this thing. I'm just trying to show you that for every power of I, it's going to be one of these 4 things. So when you simplify powers of I, you're either going to get I, you're going to get negative 1, you're either going to get negative I, or you're going to get positive 1. It'll be one of those 4 things. No matter what your exponent is, as long as it's an integer, you're going to get one of these 4 things. Okay, so if you look at I to the 7, just to show you, I to the 7th, remember, always use I squared. So I'm going to rewrite I to the 7 as I squared, and then you ask yourself 2. Now, this is not even, so think about it this way. 2 goes into 7. 2 goes into 7 how many times? Well, it goes 3 times, right? And with a remainder of what? 1. So this is going to be 2 times 3 is 6 with a remainder of 1. So I to the first power. So 2 times 3 is 6. 6 plus 1 is 7. So you always want to use the largest exponent possible. Okay? Always use the largest possible. Okay, so I squared we know is negative 1 raised to the third power, negative 1. That's negative 1 right here. Times I, and I know that a negative number raised to any odd power is negative 1. And so negative 1 times I is a negative I, and that's what we saw here. Okay? All right, so let's look at some examples. So the point of this is just to show you that no matter what exponent you have for powers of I, no matter what exponent you have, and again, as long as those are integers, you're going to get one of these 4 answers. So when you simplify powers of I, you're going to get either I, negative 1, negative I, positive 1. Okay? So let's look at some examples. So, number 1. So the directions will say simplify. Or it could say, so the directions will look like this. Depending on your textbook, it could say something like simplify. It could say simplify using in terms of I. You could say something like this. Okay? All right. So, or it could just say simplify powers of I. But just know that those are the directions that you will probably see. Okay, so number 1. So suppose we had I to the 70th power. I to the 70th power. Now that's a big exponent. It's a large exponent. So you don't want to keep saying I squared times I squared times I squared. Okay? What you want to do is this. You want to use I squared. You're always going to use I squared with these because you know that I squared equals a negative 1. Okay? So that you know. So you can ask yourself, I squared, and remember using a power to a power, using one of those properties you learned from a previous course. So 2 into 70, so you ask yourself 2 divided into 70 is 35 times, right? And then 35 times 2 is 7, remainder of 0. So basically what that means is that when that number that goes here, I'm not going to need anything else. So 2 times 35 is 70. And so I'm done with that part. I just got to work with this a little bit further. So I squared, we know, is negative 1 raised to the 35th power. And so negative 1 raised to any odd power is negative 1. So I to the 70th equals negative 1. So there's your answer. Okay? So remember, it's going to be one of those four things. One of these four possible situations. Number 2, suppose I had I to the 39th power. I to the 39th power. All right, same thing. If you need to use your calculator, use your calculator. So remember, you're going to rewrite this as I squared raised to a power. All right, so you're asking yourself 2 divided to 39. So 2 divided to 39. And again, you have a calculator, so use that. So 39 divided by 2 gives me 19. And then 19 times 2 is 38 with a remainder of 1, right? So this becomes 2 times 19 is 38, and then times I. So remember, that's I to the 38th power, so 38 plus 1 is 39. So just notice or use some concepts that you learned in the previous course. Then we're going to use the fact that I squared is negative 1. So this becomes negative 1 to the 19th power times I. And so negative 1 raised to an odd power is negative 1. So negative 1 times I gives me negative I. So what I found is that I to the 39th power equals negative I. So that's what I found. Okay? Number 3. So number 3, let's suppose you have I to the 43rd power. I to the 43rd power. Okay. Same idea. So you're going to rewrite this as I squared raised to a power and some remainder, because you know you're going to have a remainder here because that's not an even number. So if it's even, then that's easy to deal with. But since it's odd, you know you're going to have a remainder. You're going to have a remainder when you do that division. So you're going to say 43 divided by 2. And so when you do 43 divided by 2, 43 divided by 2, you're going to get 21. And then 21 times 2 is 42 with remainder 1. All right, so whenever this is odd, notice the pattern. Whenever this is odd, what will this, and you're dividing by 2, what will this remainder always be? Well, it's always going to be a 1, right? So you just got to know what number goes here. So the number that goes here is this quotient, so that's 21. Because 2 times 21 is 42, and you get a remainder of 1. So that's where you get that I from, I to the first power. So you're always going to have a remainder of 1 because you're dividing by 2. Okay, now, so I squared is negative 1, right? So we're raising that to the 21st power times I. Well, remember, negative 1 raised to an odd power is always negative 1. And the negative 1 times I gives me negative I. So what I found is that I to the 43rd power, I to the 43rd power equals negative I. Okay? Number 4. Suppose in number 4, I had I to the 86th power. I to the 86th power. Okay, so I to the 86, now that's even, right? So that's an even number, so that's going to be easy to deal with. I'm not going to have a remainder because 2 goes into this evenly. So I'm going to have I squared, and then 2 times what's 86. So if you can't do this in your head real quick, you have access to a calculator. Just say 86 divided by 2, and that gives you 43. All right, and so I get I squared, remember, is -1, and -1 raised to the 43rd power. So -1 raised to an odd power is going to be -1. So what I found is that I to the 86 equals -1. And so as we continue on, I want you to notice, remember when we had that discussion, this pattern? So whenever you simplify powers of I, no matter what it is, if you kept on this pattern, you're going to see that you're going to get I, -1, -I, 1. I, -1, -I, 1. I, -1, -I, 1. You're going to get that pattern. So this would be I to the 9th, this would be I to the 10th, I to the 11th, I to the 12th, and so on. All right, but you don't memorize that. That's not the whole point of this. So students don't memorize this. They just remember that when you simplify powers of I, you're going to get this pattern. And so basically what you're going to end up with will be either I, -1, -I, 1. And the way they remember it, and they do it logically, is that they know that I squared is equal to -1 from previous lessons and from what we just saw a while ago. I squared equals -1, and they just use that to simplify these powers. All right, and so if we look at number 5, let's look at number 5 for a moment. So suppose at number 5 I had I to the 88th power. Let's think about that. I to the 88th power. Okay, so I to the 88th power, I'm going to get I squared raised to a power. Now, since that's even, I'm not going to have an extra I there. So I squared, 2 times what's 88. So if you don't know real quick, use your calculator. So that's going to be what, 44? So this becomes -1 raised to the 44th power. So a -1 raised to an even power is always going to be a +1. All right, so -1 raised to an even power is always going to be a +1. So what we found is that I to the 88th equals a +1. Okay? Now, notice that, I want you to notice something. So see when I had that even power here, I got -1. When I had that even power here, I had -1. When I had that even power here, I had +1. So and if I go to the odd ones, so if I look at the odd, when I had that odd power, I had -I. When I had this odd power, I had -I. And let's look at this one. So let's look at number 6. So let's suppose at number 6 I had I to the 45th power. 45th power. Okay, so I to the 45th we know is I squared, and so 2 into 45, and then you know you're going to get a remainder of 1 because you're dividing by 2. But 2 into 45, 2 into 4 is 2, 2 times 2 is 4, and then we get, 5, and then 2 into 5 is 2, 2 times 2 is 4, you get a remainder of 1, right? So 22, so that's I to the I squared raised to the 22nd power times I. And so notice this is -1 raised to the 22nd power times I, and a -1 raised to an even power is always a +1, and 1 times I is I. So what I was trying to get you to see is this. So whenever the exponent is even, do y'all see that you're either going to get a -1 or a +1? If the exponent is odd, you're either going to get a -I or a +I. And that's what you saw here. So if you go back to this pattern, I want you to see this. When you look at this pattern right here, so look at the odd exponents. So the i's with the odd exponents. So here's 1, so that's I, -I, I, -I, I, -I, right? If you look at the evens, you get -1, +1, -1, +1, and so on. Okay? So that's something you may want to remember. Some students don't remember that, and that's fine. But that's something you may want to remember to help you. So to help you determine if what you have is correct. Because if you did I to the 45th power and you got a positive 1 or a negative 1, you know that's not correct because that's odd. So I have to have either a negative I or a positive I as my answer. All right. And then let's look at this one. So this is going to be number 7. So number 7, let's suppose in number 7 we had I to the 120th power. So based on what we talked about, you know that the answer will either be a positive 1 or negative 1, right? Okay, so let's use I squared. So that's even, so that's going to be a nice one to deal with. So 2 times what's 20? Because remember, when you have a power raised to power, you multiply. So 2 times what's 120? So that's what, 60? And so this becomes negative 1 raised to the 60th power. And a negative 1 times itself 60 times is 1. So a negative 1 raised to an even power is always 1. Okay? And then number 8, let's suppose you had I to the 223rd power. I to the 223rd power. So yes, it can get much larger than that. So I mean, you have an infinite number of exponents you can use here. So just keep in mind, sometimes the exponent you can deal with this is much larger than a 2-digit number. So using I squared, and then thinking about this, 2 goes into 223 how many times? So 2 goes into 2 one time. 1 times 2 is 2. Bring on the 2. So, and again, you have access to calculator. And then remember, whenever this is odd, you're going to get a remainder 1 when you divide by 2. So 2 into 3 is 1. 1 times 2 is 2. Remainder 1. So there's my remainder. Remember, that's your remainder. You're always going to get, whenever your exponent, or in this case, your radicand, is odd and you're dividing by 2, you're either going to get 1 or you're going to get 1 if it's odd. Okay? All right, so this is going to be 111. 2 times 111 is 222 times I. And so this is negative 1 raised to the 111th power times I. And negative 1 times itself 111 times, or negative 1 raised to an odd power, is always going to be negative 1. And so negative 1 times I is negative I. And so and so you know that since this was odd, your answer should have been either odd or I or negative I, right? Okay. Now, we're going to change gears for right now because you could also see something like this. We're still dealing with positive powers of I. So we're still dealing with positive exponents with what I'm about to do. But just sometimes you could see this. And so just look at what you're going to do with this. So let's suppose I had negative I to the 22nd power. Okay, no big deal. Don't let the fact that there's a negative somewhere outside of I to the 22nd throw you off. So if you want to, you can approach it this way. You can think of this as being negative 1 times I to the 22nd, right? Okay. And then let's focus on I to the 22nd. So let's think about what I to the 22nd is, just like we did a while ago. So we're going to say, well, to simplify I to the 22nd, I'm going to get I squared raised to the 11th power, because when you have a power raised to power, you multiply those exponents. And so I squared we know is negative 1. And the negative 1 raised to an odd power is negative 1, correct? And so now what we have is this. So now you take what you saw here and bring it here. So I have negative 1 times the negative 1, which is a positive 1. All right, so what we found is that negative I to the 22nd power equals positive 1. So that's how you're going to approach problems that have negative beyond what we just saw in 1 through 8. All right, so let's look at this. Suppose you had number 10. Suppose this was negative I to the 105th power. Negative I to the 105th power. Okay, we'll just do what we just did. And it sometimes helps to do that. So the way I would approach this is I would write this as negative 1 times I to the 105th power, and then let's simplify I to the 105th power. So if I simplify that, I to the 105th power, so that's going to be I squared. So use your calculator. So watch. So you're going to say 105 divided by 2 gives you 52.5, right? So what that 52 means is that 2 divided to 105, you have 52 factors of 2. And I'm sorry, I did not. Yeah, okay. So 52, and then 52 times 2 is 104, remainder 1, correct? Okay. So so um, so then I'm going to rewrite this. All right, so I'm going to rewrite this as I squared raised to the 52nd power times, and remember, you got a remainder 1, so you need that I there, I to the first. And I always check. So 2 times 52 is 104, correct? And 104 plus 1 is 105. All right, so so then negative 1, which is I squared, raised to the 52nd power times I, and a negative 1 raised to an even power is going to be positive 1, and then 1 times I will be I. So that right here, though, remember that's I to the 105th, so that's I, will be right here. So we have to come back and put that here. So that's negative 1 times I, which is negative I. All right, so that's how you're going to approach those. So let's look at this one. So number 10, let's suppose at number 10, I'm sorry, number 11, we had this instead. All right, so again, don't let those the negative ones throw you off. So just use your knowledge and you'll be fine. So number 11, let's suppose we had negative I to the 24th power. All right, now, again, don't let that throw you off. The way that I would approach this is this way. I would kind of forget about that exponent right now and then just remind ourselves that negative I means the same thing as negative 1 times I, right? Okay, now remember, that's all being raised to 24th, though. All right, so that's the way I would approach this. And then remember, in a previous course, you learned this property. And the property was this, that if you have a product, A times B, raised to a power, then I can rewrite this as the product of each factor raised to the power. So A to the C times B to the C. Okay, and so that's what I'm going to use here. So this becomes negative 1 to the 24th, just like this, times I to the 24th. All right, so that's what we saw here. Okay, all right, and so we know that negative 1 raised to the even power is a positive 1, and all I have to do is figure out what I to the 24th power is. So I to the 24th, to simplify that, I'm going to say I squared to the 12th power, because 2 times 12 is 24. And so this becomes negative 1 to the 12th power, because I squared is negative 1. And the negative 1 raised to an even power is always a positive 1. So what I found is that this factor right here, I to the 24th, is also 1. And then 1 times 1 is 1. So what we found is this then. So we're going to say negative I raised to the 24th power is equal to a positive 1. All right, and so let's look at number 12. So number 12, let's suppose you had this. And number 12, let's suppose you had negative I raised to the 49th power. All right, again, don't let something like this throw you off, and don't make it difficult on yourself. Be strategic with this. Think about something you already know how to deal with. I already know that negative I means negative 1 times I, and then that's being raised to the 49th power. And I also know that I can use this property from a previous course. So each of these factors I'm going to raise to that power, to that exponent. So that becomes negative 1 raised to the 49th power times I to the 49th power. And so this part here, negative 1 raised to an odd power, I know is negative 1. And then all I have to do now is figure out what I to the 49th power is. So let's go ahead and do that. So I to the 49th, we're going to simplify. So that'll be I squared. All right, so 49 divided by 2. 49 divided by 2 goes a whole 24 number times. So it'll be 24 right here. And then 2 times 24 is 48, so I get the remainder of 1. So it'll be times I. And so this becomes I squared, remember it's negative 1, raised to the 24th power times I. So notice how we're doing this. So step by step. And so a negative 1 raised to an even power, we know is going to be a positive 1, and then 1 times I is just I. So now be careful, that right here is just this now. All right, so some students will automatically put the answer as I, that this is, without thinking, hey, I forgot about this part here. So just make sure you're going step by step. All right, so remember what we did here was we came off to the side to figure out what this part is. So now I know that this I to the 49th is just I. And so now a negative 1 times I is a negative I. And so the answer is negative I to the 49th is just negative I. And so notice as we keep on with this, do you see that you get, whenever you're dealing with powers of I, you get one of these right here. I, negative 1, negative I, 1. Get one of those whenever you simplify powers of I. Let's go to 13. So it is possible you could see something like 13. Let's suppose we had, now be careful with this one. So let's suppose we had 2I to the third power. Okay, so it's okay. I'm going to use the same idea I used here. I'm going to use this property I learned from a previous course. So I know that I can write this as 2 to the third power, correct? Times I to the third, right? All right, and so 2 to the third I know is 8. Now let's talk about I to the third. So I to the third, remember, is I squared times I. And so I squared is negative 1. Negative 1 times I is negative I. All right. Now, I would say this. I would say, as you practice this, you really need to learn these first four. I is I squared is negative 1, I cubed is negative I, and I to the fourth is positive 1. That's what you need to remember. And so I cubed, you should have already known that was negative I. But if you did, and no big deal, you just go ahead and work it out. And so I cubes negative I, so this becomes times negative I, and 8 times negative I becomes negative 8I. And so we found is that 2I to the third power equals negative 8I. Okay? So that's what we found. All right, number 14. Let's look at 14 real quick. So see, it's not that bad. Simplifying powers of I is not that bad. It's not a difficult situation. So in 14, let's suppose we had this in 14. Or in 14. Let's suppose I had negative 3I to the fourth power. Okay, negative 3I to the fourth power. All right, don't make it difficult. Just remember what we just saw a while ago. Using our property. So using our property, I know I can write negative 3 to the fourth times I to the fourth. So this becomes negative 3. Make sure you put that in parentheses though. To the fourth times I to the fourth. Now this I did not need to be in parentheses, but this did, because you're raising this negative number to the fourth power. So it had to be in parentheses, because remember, if you use your calculator, I just want to show you, negative 3 to the fourth, if you say this right here, negative 3 raised to the fourth power, I want to show you what you're going to get. You're going to get a negative 81. But remember, a negative number, that negative number is being raised to an even power. So a negative number raised to an even power should always be positive. So that's why that parentheses was necessary. So put parentheses. So parentheses, and then you say, what was it, negative 3? So you say negative 3, and close the parentheses, raised to the fourth, and you're supposed to get positive 81. Okay? So this right here is positive 81. Now let's go about I to the fourth. Well, remember, I to the fourth is one of those you should remember. But if you don't, just think about it this way. I to the fourth will be I squared raised to the second power, because 2 times 2 is 4. And so I squared is negative 1. And negative 1 raised to an even power is a positive 1. And so that becomes 81 times a positive 1, which is just 81. So negative 3 I to the fourth is equal to 81. Okay? All right. So I think that may be enough for you to understand simplifying powers of I. Now remember, what we did here was we simplified powers of I in which the exponents were positive. So in the next lesson, we're going to look at, well, what if this is I to the negative 23rd power? What if this is I to the negative 48th power? What if this is I to the negative 72nd power? So that's what we're going to talk about next lesson, dealing with powers of I. But so one of the things you got to recall, though, even in the next lesson we talk about it, is that the fact that I, that square root of negative 1 is equal to I, and then from there we see that I squared equals a negative 1, and then we just went from there. Okay? All right, so that's going to be the end of this lesson.